if you need to retake the AccuPlacer, talk to me about a time that you can do that. And if you don't have a time, let me know. We can figure out a time I can send you to the computer lab during class time, and then you can just get the notes later. But you can take that 3 times, so just let me know if you want to redo that. Also, don't forget about test corrections for Chapter P and the retest. I had a few people that took the retest yesterday. If you want to retake that test, you have until Friday after school. Even I'll be here after school Friday if you want to do that. And don't forget that even if you don't want to retake it, that test corrections are due Friday by 3:30 as well. That is a 10-point assignment. Even if you only miss a couple questions, that's a 10-point assignment to do that. So keep that in mind. We're going to start Chapter 1 today. This first section isn't that bad. It's kind of just like reminding you about equations, reminding you about how to solve problems, and just a few random stuff. And then very quickly, this week we're going to get into the types of equations that you should recognize by both graphs and equations. Quadratic stuff again. I don't know, just a bunch of different stuff that's all thrown in this chapter. And so today we're kind of really talking about the different ways that we deal with functions, numerical, algebraic, and graphical, because that's kind of, if calculus is your next step, we want to make sure that we can deal with functions in all 3 ways. Okay, so there's a few lots of story problem stuff in this, and we'll talk about you don't have to write every word of it down. You can just kind of summarize what you need here. Okay, so this section is called modeling and equation solving, which I think again is like a big hodgepodge of what you've known how to do for a long time. In calculus, we say that we can solve an equation or we can deal with equations in 4 ways. One of them is using a table, right? And you've been doing that for years, right? That would be like an XY chart. When you pick values for X and you plug in values for Y. And actually part of your homework today, they give you a bunch of XY charts and they give you a bunch of graphs and they want you to match them up, and people always kind of freak out about it. We'll talk about that at the end of the notes. I'll let you get your homework out and we'll kind of look at one of them of patterns you can look at. Graphs, you've also been doing graphs for years, matching graphs, making your own graphs. And probably the way that most of us are most comfortable with working with functions is actually the analytical way, like looking at equations, solving equations. Sometimes if they don't give us an equation, we feel like we don't have enough information. In calculus, we add a 4th way, and we add that we should be able to deal with functions verbally, which means in calculus, you're expected to be able to write about your equation and explain your answer, but we don't really do that so much in this class. All right, but today we are going to be using all 3 of these, XY charts, graphs, and equation. So let's just start with a good old story problem here. And again, you don't have to write every word of this. Maybe you could just draw pictures. Let's read through it and you can decide what you want to write down. But it says a pizzeria sells a rectangular 20 by 22-inch pizza for the same price as its large round pizza with a 24-inch diameter. If both pizzas are the same thickness, which option gives you the most pizza for the money? So again, kind of one strategy as you're getting ready to go to college is how to be able to take notes without feeling like you have to write every word down. If this were me, I would write 20 by 22 inch, or you could even say, look, this is a very not accurate picture here. I'm just going to say 20 by 22. Does that really make you feel like that's really wrong? That's okay. Don't trust the picture, right? 20 by 22 inch pizza and 24-inch diameter pizza, and I would say which gives the most for the money, right? Like you could write down and know what that problem's asking by just saying like which gives the most for the money and draw the picture without having to write every word of it down. Tomorrow the notes are going to be really, really wordy, so probably I'll print them out for you tomorrow and just kind of leave blanks for you to fill in, but today we can kind of summarize it. It seems like most pizza places do circle pizzas now. Do you know a pizza place that still makes rectangular pizzas? Pizza Hut, they have that one pizza with the box with the things in it, right? Little Caesars, do they still make rectangular pizzas? Back in the old days, Little Caesars had a pizza called the Bigfoot pizza, and it was like 2 feet of pizza. Like it came out like this big cardboard thing, and it like was this long. That was way before. You were like probably not born then. So. What will we do here to figure out which pizza gives us the most pizza for the money? What's wrong? Favorite pizza? Oh, just pizza. I should have brought pizza. Do you eat cold pizza? Cold pizza for breakfast is the way to go. Hot pizza for dinner, cold pizza for breakfast. What should we do here? I know you know. Maddie. Yeah, we want to find which one gives us the most for the money. We want to find the most area, right? And so this is just some good old reminders. How do you find area of a rectangular pizza? Length times width, right? Area is length times width. So 20 by 22. That sounds like a good size pizza. I got 440, and just a reminder, if we're talking about area, and this is inches by inches, then we would say that's square inches. And what about for a circle? How do you find area of a circle? What? Pi r squared. So just be really careful, right? They gave us the diameter, not the radius, so don't plug 24 in there. Again, this is where you have to think about what's reasonable, right? Normally, if this was not a story problem, I would say 144 pi is a really good answer because it's an exact answer. But comparing 144 pi to 440, right? Like that's a little bit harder to do. So that's where a decimal is better because we're talking about a real life situation. 452.4 square inches. So which pizza gives you the most for the money? The circle pizza, right? Or round pizza, I guess I could say. Who says circle pizza? Maybe that's why people make round pizzas? I don't know the answer to that question. Maybe it's just easier to make dough in a circle than in a rectangle. Alright, I don't speak for you now. Alright, so there's some like random story problems in here. There's also just some mixed in regular algebra problems. So let's see what else we have. I like this. We just did this on chapter P. So it says solve the equation x squared equals 8 minus 4x algebraically. So that means not using a graph. I'm going to just rewrite that. And like I said, in chapter P, they were just reviewing a few things. We reviewed quadratic formula, we reviewed factoring, we reviewed completing the square. And that's exactly what you're going to use to solve this. And again, I'm not pressuring you to use one way over the other. I just want you to be able to solve it whichever way you feel most comfortable with. If you're going to do any of them, you really need to kind of get those x's on the same side. If you wanted to complete the square, we didn't have to necessarily move the 8 over, but I'll just move everything over. So I'm going to add the 4x and subtract the 8 over. And again, for me, I always look for factoring first because I like factoring. But if you hate factoring, go ahead and complete the square here or do the quadratic formula. But I think, no, I can't factor that, can I? Oh, factoring doesn't work. So are you going to do the quadratic formula? You guys love the quadratic formula. I love completing the square. I'll do both. I say I'm not trying to force you to do one thing or the other, but it seems like I kind of force you like to want to complete the square. This is a perfect one for completing the square, and you don't have to stress about the mistakes that people make in the quadratic formula because there's nothing in front of the x squared. The middle number's even, so all I have to do is take half of that number and square it. Half of 4 is 2. 2 squared is 4. So I add that to the other side. And then I'm going to factor that into x plus 2 squared, because that's 1 multiplied to give me 4, that adds to give me 4. And over here I get 12. So I'm going to take the square root of both sides. I'm going to come up to the top here. And I'm going to get x plus 2 equals plus or minus. And when I break up my square roots, I know Mr. Oswald taught differently than I do. He taught you to do the prime factorization. But for me, I always think about what two numbers multiply to give me 12. If one of them is a perfect square, then I can simplify it. So for me, I'm going to break 12 up as the square root of 4 times the square root of 3, because I know that that would just give me 2 square root of 3. The prime factorization way works too, where you work it all out and then you circle the ones that repeat themselves, but I've just never done it that way. So my answer is negative 2 plus or minus 2 radical 3. Which means if you did the quadratic formula, which I'll do really quick here, there was a simplifying step because there's no fraction. That's how I know you could have simplified it. So if you did the quadratic formula, you should have had negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times negative 8, all over 2 times 1. Is that right, underneath the radical? All over 2. This is where on chapter P people made mistakes. Either they just left it like this, so they missed a point for not simplifying, or they simplified incorrectly, so they missed a point. So again, not that I'm saying you can't do the quadratic formula, but sometimes if it's an easy completing the square problem, you might not make those simplifying mistakes. But again, what's wrong? Oh, words. I didn't hear that. Breaking up 48. All right, so this is where maybe you wouldn't, I don't know. Maybe Mr. Oswald's way is better. I don't know. I've just never done it that way. I argued with him last year when I found out he was teaching you that way, but there was no convincing him. So my way, you might say, well, 4 goes into that, but 4 goes into that, what, 12 times? And then 12 still has another perfect square in it. So that's where, for me, I think about what's the biggest perfect square that goes into 48. And so for me, I would break that up as the square root of 16 times the square root of 3. Or if you broke it up as 4 and 12, then you just have to break up 12 up as 4 and 3 again, and you would still get that. Again, prime factorization works. I just sometimes think it takes a lot of work. Like you have to work it all out to get all the prime factors, where if you can just think about perfect square numbers, it doesn't take as much time to do that. Either way you do it, or however you do it, you should get negative 4 plus or minus 4 radical 3 over 2. Those are divisible by 2, so I think we get the same answer that I got with completing the square. Yes? So again, I don't care which way you do it. I just care that you get to the right simplified answer. To me, completing the square was way less work on that. If there was a number in front and I would have got ugly fractions, yes, quadratic formula is probably simpler. But when it's even, I find completing the square is less work than simplifying all that. So, just my 2 cents on the matter. Questions about that? Again, we just did that in chapter P, so hopefully if you're planning a retest on chapter P, this will kind of help you review that. All right, connecting roots, zeros, and x-intercepts. And again, it's up to you on how much you want to write down here. Maybe you know this, but you have to know that these words mean the same thing, and so your book kind of spells it all out for you, like this means this. I think I used to have a test in Algebra 2. I'm sure Mr. Oswald didn't use it. Mr. McClure always used my tests. But I always had a test when we talked about this in Algebra 2 that said, like, what 3 words mean the same thing as a solution? Because I want you to know that roots, zeros, x-intercepts, and solutions to an equation all mean the same thing. They're all really kind of interchangeable words. We use them differently depending on if we're talking about a graph or an equation. But if you solve an equation, right, so it says if A is a real number, that solves the equation f of x equals 0. So if you have an equation equal to 0 and you get some answer, like, well, let's go to it, like x equals a, then these three statements are equivalent. And if you write anything down, I think the three statements are worth writing down. It's not too small. Can you see that back there? The number a is a root or solution. Those words mean the same thing. A root or solution of the equation. I say solution most of the time if I'm talking about the equation. I say root if I'm looking at the graph, but you can say them interchangeably. The number a is also a 0 of the function y equals f of x. So notice when you take the 0 out here and you set it equal to y, you're now talking about the graph, and so it changes. But when you set an equation equal to 0, you're finding the zeros. And lastly, the number a is also an x-intercept of that graph. So those four words to me, I feel like coming out of Algebra 2, one of the big things I wanted you to get out of Algebra 2 are that root, solution, 0, and x-intercept are all what you get when you solve an equation. Any kind of equation, whether it's a linear equation or it's something to the 5th power that has 5 zeros, those words are pretty much interchangeable there. Right, I don't really give vocabulary tests, but the vocabulary is in the directions of a problem, right? If it said find all the roots, you need to know, oh, I just set that equal to 0 and I solve it. Or if they give you the graph, oh, that's just looking where it crosses the x-axis. So that's where vocabulary really comes into play in algebra, pre-calculus. Okay? So maybe somewhere if you want to say, like this would be like the solution is x equals a. You could even throw something in there that the factor would be x minus a, but you don't have to write that yet if you don't want. We'll get there. Okay. You're good writing? I'm going. You don't really have to write this down either. I just thought it was funny that they give credit to this guy for how to solve problems. But I find this book to be kind of a funny math book. Some math books are terrible. The authors of this book kind of make me laugh sometimes with what they write in here. So every now and again, I'm going to put something in the notes just because I'm going to force you to read it or me read it to you. And then sometimes I like to give random extra credit questions about people's names on the test or quiz, just to see if you listen to me ramble on. Polya, here we go. George Polya, who died in 1985, not that long ago, is sometimes called the father of modern problem solving, not only because he was good at it, as he certainly was, but also because he published the most famous analysis of the problem solving process, How to Solve It, a new aspect of mathematical method. And his 4 steps are well known to most mathematicians. And I just thought it was funny that in this pre-cal book they tell you that these are the steps that you should take when you solve any problem. And they're good steps, right? I always say, even when I teach like ECA Lab, step 1, understand what the problem's asking. I don't always do it, but smart thing to do is read the problem before you start writing stuff down, because sometimes you start doing something and you haven't even finished the problem to see what you're supposed to do. Devise a plan. I don't know that we all sit there and think about what plan we'll take, but am I going to factor it? Am I going to draw a picture? Am I going to set up an equation somehow? Am I going to graph it? Carry out the plan is actually solving it. And then this is probably the most important step that we don't do is, does it make sense in the problem? Later on in this book, we'll do some interest stuff, and we'll talk about car payments and house payments. And I always give this question about, you're buying a car for $4,000, and you're going to finance it over 3 years. What should your car payments be? And people give me answers of like $6,000 a month when the car only costs $4,000. And that doesn't make any sense. Or they give me answers of like 0.27, so like their car payment is 27 cents a month. That doesn't make sense either. And so, especially in a story problem, you always want to say, does my answer make sense? And so, not that I'm ever going to test you over what are the 4 steps, but sometimes I think especially with story problems, we tend to think that we don't know how to do it, but if you just kind of think through it, see if your answer makes sense, is reasonable, that's an important step. Plus, I just think it's funny that some guy gets credit for saying this, because I think it should make sense that people. Okay, you gotta write that down, but you should write this down. You should read your book every now and again. We're almost done with the notes, if it makes you feel any better. Again, this section is called modeling and equation solving, so they just throw a bunch of stuff in together, like this with a radical in it. What is the first step you have to do if you have an equation with a radical in it? How do you do that? Yeah, we have to square it to cancel it out. If there was something added or subtracted next to this radical, you'd want to get rid of that first, because otherwise it's going to be a big mess. But since this radical is by itself, if we just square it, that's going to cancel out. But the only way we can square it is if we also square the other side. So just be really careful. That's not just 4x squared plus 25 over there, right? Like that's FOILing that out. 2x minus 5 times 2x minus 5. Twice, you're going to have a middle term there. So we get 4x squared minus 20x in the middle plus 25. Because it's minus 10x minus 10x. And then over here, the square root and the square, those are inverses, so they do cancel each other out. And now we're back to the one that we just did. We have a quadratic here. We did some like this in chapter P2, where we just need to combine like terms. I'm going to subtract my 4 over, subtract my x over, minus 21x plus 21. Is that true? Let's check my arithmetic because it could be wrong. Would this be one I would choose to complete the square on? Probably not, because I'd get 21/4 there. And we could do it, but probably let's just quadratic formula. You want to do that? We could try to factor it, but I don't want to try to think about things that multiply to give me 84. And again, I always just do that whole radical, like what's underneath it on my calculator. I don't write negative 21 squared because I know it's going to be positive. Minus 4 times 21. I got 105. Now, square root of 105 is not pretty, but it's a lot better than some square roots we would get, because I don't even think we can simplify this. Right? It's not even, so we don't have to worry about like 4 going into it. Perfect squares. 3 goes into it. I could check and see and make sure. 3 and 35. 35 doesn't have any perfect squares in it. So that's where the way that I simplify radicals is by just thinking about perfect squares. I can figure out very quickly that this does not have any perfect squares that goes into it. So I'm just going to leave my answer like this. You could break it up if you want, but I'm just going to leave it as one big ugly answer. One thing I do want to caution you about, and I think there's one on your homework like this that we'll probably talk about tomorrow. If this was a nice answer, you have to make sure, well, I guess we could even check this one. You have to make sure when you plug it back into the problem that you don't get an imaginary number, right? Because there's a square root up here, we have to make sure that what we plug in isn't going to make one of those extraneous solutions where we get an answer that doesn't work. I don't think that's going to work on that one, but I'm going to do the negative really quick. 21 minus the square root of 105 divided by, oh, that's a positive number still. So these are both positive answers. 2 positive answers. So do you agree that there's no way I could get an imaginary number under that? But if I had an answer, let's just pretend I solved a problem and I got x equals -6 and x equals 2. Okay, now I know neither one of those are going to work in this problem because they don't work. But if you got answers like this, you have to check. If you would plug -6 in there, you would get the square root of -2. There's no way the other side could ever equal the square root of -2. So that's where it's an extraneous solution and you have to mark it out. You have to remember to check your answers. And so we'll talk about that tomorrow because I'm pretty sure I gave you one on homework that one of the answers doesn't work. So extraneous solutions. You always have to do that with there's an x in the bottom also. You have to make sure it doesn't make the denominator equal to 0. So just be careful on that. How about that? I plan to get out with these notes early because the beginning of the homework always confuses people. So what I want you to do is I want you to write this down, get your book out, look at those first questions, and then I'm going to talk about it for a second. So I'm going to just be quiet for a minute and let you write this down. I think I have assignment sheets for you. And go ahead and get your paper out for your homework and get your book opened up. Okay, so first off, I just want to kind of explain what this is saying. On 1 through 10, it says, match the numerical model to the corresponding graphical model A through J. So 1 through 10, there are XY charts. Then there are choices A through J, which are graphs. But then there's also choices K through T, which are equations. So they're trying to show that for each problem, you can model it as a table, as a graph, and as an equation. So that's one thing. Each number 1 through 10 should have 2 letters next to it, okay? On the charts, most of the time we make our XY charts vertical, but they do it horizontally, so the X is on top and the Y is on bottom. But each one of those is like an ordered pair, 3, 6, 5, 10, 7, 14. So we'll talk about that in a minute. Maybe we can look to see, like, is it linear? How do you know is it linear? Is it quadratic? How do we tell these things by looking at the chart? The graphs, I'm not going to draw all these up here, but I just want to show you what they do, right? The graphs kind of all look the same, but how do you know when they're different or what they're going by? The numbers at the bottom are the windows, and they kind of use that calculator speak where we use that window button. So this is your x-axis, and this is your y-axis. So for letter A, they're telling you that your x-axis goes from -2 to +14. And that your y-axis goes from -4 down here to 36. So very quickly on some of these, you're going to see the really big numbers. Like look at H. H, the y-axis goes to 100, and J, the y-axis goes to 650. probably you can look at those XY charts and match those up pretty quickly with the ones that have the great big numbers on it, right? That's kind of quick and easy to do. On some of the other ones, you're going to have to do a little bit more work. So like look at number 1. For me, what I tried to do first is do all the ones that were linear or had a slope, kind of figure those out. So like on this one, do you see on the x-axis, what is the x, is it going up by the same every time? It does for a while, right? You see how this is plus 2, and then 5 plus 2, and then 7 plus 2? Yes? If it's linear, what should happen if the x is going up by a constant change each time? What should happen on the y part? All right, first of all, what's slope? Maybe we need to go back to that. Rise over run, what does that mean? Y over x? Change in y values over change in x values, more specifically. If I had points here, could I find the slope of this chart? Yeah, I could pick 2 points, I could subtract the y's on top and the x's on bottom. But that only works if it's linear, right? Slope has a constant change, right? Like up 2 over 1, up 2 over 1, up 2 over 1. That would be a slope of 2. Yes? On this one, do you see how this is going up by plus 4, plus 4, plus 4? If that number is the same, when the x's are changing the same, is that a linear equation? Yeah, that's the definition of slope. You got to be careful, though, because then it jumps from 9 to 12, and so then it jumped by 3, so don't let that trick you on that. That's why I stopped after 9 here. But that's the same. What would that slope be? Or how could I find the slope of that? What's the formula for slope again? That's slope-intercept form of an equation. But how do I find the m if I just have a chart? Change in y over change in x. Or as Lois says, y2 minus y1 over x2 minus x1. What is the y's changing by on here? 4 over what were the x's changing by when it was constant? 2, which means this would have a slope of 2. You could do the same thing on here. You're still going to get 2. What is the y changing by from 18 to 24? It's changing by 6. 9 to 12 is changing by 3. Right? It's still slope. It's just changing by a different number. That means that this has a slope of 2. So look at your choices K through T. K through T. Which possibilities have a slope of 2? Are there any equations down there on K through T that have a slope of 2? Q possibility is y equals 2x, and S possibility is y equals 2x plus 3. How do you know which one it is? Take a wild guess. Look in the back of the book. Use the chart. If I plug in 3, which one of these equations will give me 6 for y? Q or S? Q, right? Because it's just doubling it. 5 to 10, 7 to 14. So for number 1, I know Q is the number for the equation. And yes, maybe you could have just seen it was doubling, but I'm trying to give you strategies here. So now look at the graphs. For me, it was easier to do the equation first and then the graph, but maybe it's easier for you to do the other way. What would the graph of y equals 2x look like? You got to be careful because the windows are different. but that's just going to be a straight line with a positive slope with 0 as the x, the y-intercept, right? So starting at 0, 0 with a positive slope. Which choice does that have to be? There's only one that goes through 0, 0 with a positive slope. D. Right? People hate these questions because it really makes you think a little bit to kind of go through and do possibilities. There's probably writing all over your book from these. Definitely it's nice to do process of elimination. If it doesn't go up at a constant rate, it's not linear. So for me, I kind of did those linear ones first and worked those out. All right, so don't, after 10, it's not that bad, I promise. 1 through 10, you just have to think a little bit and kind of work your way through. And we definitely can talk about it more tomorrow. But that's kind of the process that I want you to think through as you're doing that. The one that's definitely not. Yeah, like look at even looking at number 2. Look, the x is going up by 1. But the y is definitely not going up at a constant rate, right? It's going up by 1, and then by 3, and then by 5. So that's not linear. So you know for sure that 2 is not going to be one that's in y is in x plus b form. Okay? Use the equations to help you to do that as well. All right? So that's homework. You have a few minutes left to start on it if you want to ask me questions on it, or if you have questions over the other stuff, and then work on the other stuff. If you get stuck on 1 through 10, don't just stop and don't do the rest of the homework, right? Like number 1 through 10, at least do the rest of it, and then you can come back and get some questions answered. I do have NHS in the morning at 7:50, so I won't really be available before school, but we can definitely talk about a couple of these in class if you have questions.